Alright, hello everyone, so welcome to my new video. Okay, so in this video we are gonna learn how to integrate a trigonometric function that contains an odd power. Now before we go there, remember what happened in the last video. When we have a trigonometric function to integrate that contains only even power, we use double angle identity, right? We use double angle identity over and over again and again until we get a trigonometric function, or until we convert the trigonometric function that we want to integrate into a function that contains only power 1 trigonometric functions, and then we integrate that converted function, right? So that's what we did. Alright, so how about if your trigonometric function contains at least one odd power? Now how do you integrate here? Alright, so let's learn. Now when you have at least one odd power, you will not use double angle identity. Okay, remember that. Now solving these type of integrals, that means when you have an odd power, it involves a lot of steps. Okay, so I want you to understand these steps very carefully, and I want you to ask the question, why are we doing certain steps? So try to learn and try to understand the reason behind every step that we are going to do. Okay, alright, so let's look at this problem. I'm going to explain this from an example. So we want to integrate sine cube x cosine square x. Alright, now the problematic term here is this sine cube, right? Because even powers are fine, right? We know when we have even powers we can use double angle identity, but here we have an odd power. So now think about the two identities. So sine square x is equal to 1 minus cosine 2x over 2. This is the double angle identity. And the Pythagorean identity is sine square x is equal to 1 minus cosine square x, right? Alright, now no matter what identity you think here, when you think it in terms of sine cube, it is impossible to use both identities, right? Think about this. How can you create sine cube out of sine square? How can you create sine square out of sine cube? Sine cube out of sine square, I'm sorry. So it's near impossible, right? You can, but it's gonna look messy. Alright, if you have been asked to create sine to the power 4, then you can just square it. Any even power is fine, right? We saw that in the previous video. So really, when you have an odd power, either identity is problematic. So then what are we going to do here? Well, let me show you something. The trick here is, when you have an odd power, split the least odd power that you can see in the trigonometric integral. So here we have sine cube. What do I mean by splitting the odd power? That means you can write sine cube x as sine square x times sine x, right? We can take out a 1 sine x. It's like 2 to the power 3 is 2 to the power 2 times 2 to the power 1, right? So we can do same here for sine cube. Take out a 1 sine. So whenever you see an odd power for a trigonometric function, always split it. Now the splitting rule is always you take out a 1 trigonometric function, just like sine or cosine. So think like cosine to the power 5. When you split it, you split it like cosine to the power 4 and cosine. You just take out a 1 cosine, okay, 1 function out. Okay, alright, and make sure you split the function with the least odd power. So let's say you have sine cube x times cosine 5x. Now for both functions you have odd powers, right? 3 and 5. Now only split the least odd power function, which is only split sine cube. Let cosine 5x be like that, okay? Alright, now why is the reason? Well, if you split the least odd power, it reduces the workload. You're very welcome to split the highest odd power, then you have to do lots of more steps. It's going to be messy, okay? But you can solve the problem if you still split the highest odd power, okay? Alright, now I'm talking too much here. Alright, so we split the least odd power. Now, still we have an odd power, right? I mean, 1 is a odd number, right? Sine to the power 1. 1 is odd. Now what are we going to do here? The next step after you split is make a u substitution. Yes, you heard me right. You're gonna do integration by substitution. Okay, now be with me. Here the substitution is going to be u is equal to cosine x. Now wait a minute, how did I choose it to be cosine x? Because what is the inside function? That is what you think when you think about integration by substitution, right? But not here. The rule to choose the u here, substitution, is very easy. The substitute that you choose should be the opposite function that you split. For example, there's only two choices for you. It's either cosine or sine. Remember that. Now think, what did you split? Okay, I split sine, then my substitute is cosine. So if you split a cosine function, that means if you had like cosine cube and if you wrote it like cosine square and cosine, your substitute is going to be opposite function sine. So your u is the function that you didn't split. And always remember, you don't choose like cosine square, sine cube as your u. It's either going to be cosine or sine. Cosine to the power 1 or sine to the power 1. Okay? Alright. Now you will be like, wait a minute, why are we doing this all? What is the purpose? What is the purpose of all these tricks? Let me show you. Now why did we choose the opposite function? Let's do the substitution. Now here's a common mistake that you always do. Don't forget that integration by substitution involves two substitutions. What is that? Replace u and also dx. Okay, so differentiate u. Du over dx is negative sine x, right? If you differentiate cosine, you get negative sine. So dx is actually du over negative sine x. Now do you see why we choose opposite of sine to be u? Because the problematic term is this sine, the odd function. Now see what happens. Let's substitute. Can you see this? We have sine square x here, we have sine x here, cosine is u, so this is u square, right? Dx is du over negative sine x. Now do you see? Oh, sine x cancel out. So we choose the opposite function, that we choose our u to be the opposite function that we split, because we can cancel out the function, cancel out that one sine to the power 1 or cosine to the power 1 if we choose our u to be the opposite function of that. Okay, do you see? All right, think if you had cosine here, if you split cosine, your u will be sine, and do this step and see, you will be able to cancel that cosine term. Okay, all right, so we will see more examples in the next video. Now let's see, let's not stop here. Now we have sine square x, we have a negative, let's keep it outside, u square du. Now hang on a second, this is wrong, right? Because when you do integration by substitution, you need to have everything in terms of u. But I have a function of x here, sine square x. How can I get rid of that? Well, this is where Pythagorean identity comes into play. Now u is cosine x. Sine square x using Pythagorean identity, what is it? It's 1 minus cosine square x. Now we know cosine is u, so sine square x 1 minus u square, right? Okay, so this is 1 minus u square. Let's have parentheses here so we do not mess up what's inside. Okay, all right, now do you see what's going on? So when you have an odd power, you will use Pythagorean identity after you use the integration by substitution to the terms that are remaining, to the excess terms. I want you to understand. And this perfectly match with the purpose of Pythagorean identity, right? What is the purpose of Pythagorean identity? Do you remember the very first video? We said the Pythagorean identity purpose is to convert sine into cosine or cosine into sine, to write the whole function in terms of just sine or cosine. We know u is cosine, so I need sine square to be in terms of cosine. So sine square x is 1 minus cosine square x, so it's 1 minus u square, right? And we don't care about the power here, right? Because our cosine is u. Integrating sine, rather than integrating sine square, integrating 1 minus u square is easy, right? Okay, all right, so how do you proceed from here? Well, let's foil this. So this is u square minus u to the 4, right? U square times u square is u to the 4. So let's integrate. Negative, if you integrate u square, it's u3 over 3, minus this is u to the 5 over 5, plus arbitrary constant c. Okay, so let's distribute this negative. It's negative u cube over 3 plus u to the 5 over 5. Well, this is plus t is c, right? C is an arbitrary constant. So negative c is also an arbitrary constant. Now the final answer will be, what is u? Well, u is cosine, right? So negative cosine cube x over 3 plus cosine to the power 5 x over 5 plus c. Alright, so this is how you solve an integral when you have an odd power for the trigonometric function. Okay, so what's going on here? Let's quickly summarize and do lots of problems in the next video. What's going on here? Well, when you have an odd power, the steps are split the least odd power. And remember, when you split, you only take out a one function. Okay, one power. Alright, then make a u substitution. When you do your u substitution, choose your u to be the function opposite to what you split. So if you split sine, it's going to be cosine. U is going to be cosine. If you split cosine, u is going to be sine. Now do the integration by substitution. Don't forget that you have to replace u, and don't forget to replace dx, because it will cancel out. If you do it correctly, if you will cancel out that splitted term. Alright. After that, you will most of the time will have a remaining excess term. Get rid of the excess term using Pythagorean identity. Okay, after you use Pythagorean identity, then it's an easy integral from there. Okay, all right, so I hope you grasped the idea. Okay, I hope you got the gist of it. In the next video, I will solve more problems, then you will be very comfortable with these type of integrals. Okay, all right, I will catch you in the next video. Thank you very much for watching this video. Bye bye.